Thank you, John. Thank you for the introduction, and thank you all attendees. So today it's a strange webinar. It's different from any other webinar we have made so far in terms of MDTools, because I am not going to do a lot of design work. I will take some blocks that I have designed in the past webinars. So let me just open, because my intent is to explain a bit of the Mbxml file structure that we have in MDTools, understand a bit how this file is interacting with MDTools information, and maybe give you some ideas of how you could use this information to maybe quote a manifold, create a drill chart without the need of SolidWorks or Inventor or even MDTools, and get information out of this smart file. So basically, if we are inside Inventor or SolidWorks, that does not really matter. And in fact, today I will have also SolidWorks open. From Inventor, the possibility to create an Mbxml file is hidden down. Let me highlight a bit. It's hidden down the block command. Here it is export. So with the export command from any block that we have designed, we are able to generate what we call Mbxml. XML files are very commonly used in information technology nowadays, because they contain a lot of information and are structured in a way that other programs can read them very efficiently. So let me save this block as a webinar Mbxml. And let's check how this file is structured. And then we see also how Vest has developed some new software to use the information in this file, and also something else that we could do with basic software like Excel, for instance. I'll show you how to take this Mbxml file into Excel and do some stuff with it. So let me, if you don't have, I recommend you find this software. It's free to use, XML Notepad 2007. It's very old, but still it does the purpose to understand a bit of the Mbxml technology structure. So let me open that webinar inside this XML Notepad. And as you can see here, this is the structure of the Mbxml file. If we open the same file with a Notepad, so I do open with Notepad. That's how the Mbxml file looks like, which is a bit strange. It's not very easy to understand. But if we look with a software that is supposed to read XML file, and of course you can also import in Excel, but that's not ideal. In this case, if we open with a software that is supposed to read Mbxml file, we understand that all the information are very structured in a fashion that we have the manifold name. That's a strange name I used during my webinar, aa.ipt, the version of XML file. And then we have some manifold properties. Manifold properties has several information. For instance, we have the material of the block. We can have the dimensions of the block. We can have a cost factor. Those are placeholders, basically. We can have face properties, index for each face. And we have also manifold footprints. So under manifold footprints, we find all the information that we have for each cavity in the block. So if we look at the block itself, there are some flanges. So let's see how a flange is described in the Mbxml file. So that's our flange, the footprint. The flange component ID is P. This is the envelope dimension, that strange profile for the flange. That's the cavity name. That is the footprint callout. And together with this footprint, we have the main drill, and we have also the bolt holes. And the bolt holes, for instance, is made of different steps. As a MDTools user, you are familiar with the step of a cavity. In fact, if we go to that same exact cavity and we do an edit, of this cavity, we can see that this cavity is made of 2 steps. Step 0 and step 1. Step 0 is 20 millimeter, 10, 90 degrees, 8.54, 59. And if we go here, we see exactly the same information. The step 0, 10, 20, 90, 1, 8. So basically, the Mbxml file has all the information that are needed to build the same block. And originally, this file, and if you ever use someone of the attendees I know they are using other tool to use the Mbxml file, but basically one of the main situation where you need to use Mbxml file is really to if you have problems with a file. I think frequently someone will tell you, hey, export Mbxml and import again the Mbxml. Now, instead of importing this Mbxml into Inventor, let me do that in SolidWorks. New part. In MDTools for SolidWorks, it's the Mbxml section is not on the left, it's on the right. And we have this 2 commands, export and import. Let me import the same block, the same subplate. That's not the file, that was called webinar Mbxml. So in this case now, MDTools in SolidWorks is building the same block that came from Inventor. So in this case, it's interesting. I am transforming a file made with Inventor and MDTools into a native file made with SolidWorks just by interchanging a small XML file generated from MDTools. So what I need to do that is basically MDTools on SolidWorks. And now MDTools in SolidWorks is bringing all the cavities in the correct position and is building all the block. And now it is also adding all the engravings that were also in the original block. And we let it go, it will finish very quickly. So one purpose of Mbxml file could be if you are designing a block and you have a vendor with MDTools but not on your platform, you just give him the Mbxml file, and this vendor will be able to build directly the 3D model in his own application, and then maybe he can do some refinement, adjustment, or small changes in order to do the job that you ask him to do. Or if you have a supplier with MDTools on a different platform, he still can work for you, and then he will send you the Mbxml file that you will be able to then change and design. So now, as you can see, I have the same exact block that I had in Inventor, the same exact block brought into SolidWorks. Sometimes people need also to exchange the same block between different versions of the same CAD application. So Mbxml file can be interesting because if, for instance, you need to modify a block that is made with a future version of SolidWorks or of Inventor, then what you need to do is just get the Mbxml file from the user that really made that block in the version, and then you import in your current version of Mbxml file of MDTools. So that's it in terms of what we can do in MDTools. So basically, we have the possibility to export and import all the geometry of the block in a form of Mbxml file. If you have any questions, just feel free to post, and I will be happy to answer them. What is interesting is that really all the information for the machine drawing for the geometry of that block that you have designed are stored in this Mbxml structure. In the last year, Vest has been developing a software called Manifold Edge that is a cloud application that is able to use the Mbxml functionalities in order to display and collaborate with your customer and vendors. So now I'm logging in to show you an additional use that we can make of our Mbxml file. So Manifold Edge, when you log in and you have an account, you can add a new project. So let me add my project, and my project is project number is 12345. The revision is 0, and the title is Vest Mbxml webinar. I can assign this project to a customer, and I can also assign an approver, a vendor. Let's say that the vendor is myself, and that's my vendor, and save it. So in this case, I'm creating a project in this web application called Manifold Edge. And I also got a notification that I have created a project in Manifold Edge. Now I want to upload the file that I have just made, and I want to upload the web Mbxml file. And now let's see how Vest can use this Mbxml file in a cloud application. So basically, as you can see, now I have a file that is available here, and I have also the possibility to share in Manifold Edge with my vendor, or I could share also with my customer in order to have my customer inspect the block, and not only the block, but I could also share assemblies. I show you later, and I can also send alert, so that now you will see a notification in my email that I have got some. It's coming. I heard the phone. There should be another project assigned to me, and later I will view from the vendor perspective. Now I want to see what happens in the viewer. So now I'm loading a viewer, and in this case I don't need any CAD application. And as you can see, that is the exact same block that I have designed during my last MDTools webinar, that today I opened and created this Mbxml file, and now I can view on a browser with all the information. This viewer online can take all the information that are in the XML file for MDTools, and for instance, I can view, select a cavity, I can view single nets, and I can view the position of one particular cavity. I could also ask what is the machining sequence. If you remember, I told you that the XML information has also the information for that you expect in the machining drawing for MDTools. So in this case, we can see that this is a -8 cavity with a spot face, and that's a SAE port. We can also measure wall thickness between cavities. So in this case, maybe I want to verify that there is enough wall thickness between these two cavities. And now, as you can see, a Manifold Edge is isolating using the same information. This is not a real 3D geometry. It's only a representation, visual representation in a browser of something that is available in the Mbxml information. We can also highlight angle holes. This block has some angle holes, and we can view the inclination, 6 degrees, and isolate only that particular angle hole. We also can view intersection details. So how a drill is intersecting with another one. So let's say I need to check the intersections between these two drills. And so we have the information of where the depth is starting, where the intersection is ending, and some details of that intersection. Now also we are able in this Manifold Edge to display also the plugs, and we can switch them off or on. So this is an interesting new tool provided by Vest that use the same Mbxml file standard that is developed inside MDTools and is the core of all the information of MDTools block. Another interesting aspect is that it is possible to write comment. So if you assign this project to your customer, the customer will be able to enter, view the block, and maybe say, yes, this block is good, or no, please change from one phase to another, and so on. As you can see on top, we have the possibility to view assemblies, to view DWGs, and let me make an example. I go back and go to a different block. This one, exit anyway. And this block, for instance, is interesting. In this case, I'm not viewing just the Mbxml file, but I'm viewing a complete manifold assembly of a small industrial block with the filters and valves and all the tree of components. And we can use the information of the Mbxml of the block to view the dimensions of the block, to view the position of all the cavities, and also to view all the external overall dimensions of the block. Again, with the idea of sharing the information of the design with our customers and vendors in order to get faster approval of the project without the need to go back and forth with a lot of emails and documentation sent. As well as manifold internal, we can also view the diagram. In this case, that's the diagram. And that's using another new technology of VEST called NetScheme that allows you to quickly, easily create diagrams in a browser. In this case, that's only a viewer. So I'm just viewing a schematic that is matching that particular block. So in this case, this project has the internal of the block. So now let's look also at the internal of this block, the assembly, and the DWG. So that's you probably have received emails about Manifold Edge. This is a quick overview about what Manifold Edge is and how we can use the XML information from generated by MDTools. Now I want to step back a bit, and I get back to my Mbxml file and show you how really this file can be used internally in your company organization to extract information to get different stuff. So I have built some Excel files with some VBA code. Maybe you are not very expert of Visual Basic. Let me clean up a bit this file. But in your company, for sure, there will be some skills, or we may help in understanding you the structure of the Mbxml file and also a bit of programming. So in the last week, I've been working on a couple of Excel macros. So one of the biggest problems for a manifold is how can I quote a manifold? How can I quote efficiently and quickly a manifold? That's the dream of all the vendors. How can you quickly get the information that are relevant for a quotation? I made just a small example here, so if I just click here, quote a manifold, and then take an Mbxml file and take the same file that I have just generated, let's see what happens. So now, as you can see, I have a table telling me what is the file name, what is the material name, what is the material, what is the dimension of the material, and then I have a volume that is calculating. I have a density that comes from a different table. I have a price per kilo. Those are just randomly placed number figures you could change. I have a weight, so let's say I change the price per kilo, and automatically I get different prices. I have also some interesting information, because when I make a quotation, I need to understand if there are angle holes, if there are cutouts and chamfers, if there are O-ring grooves, but there are nothing special. I have, in this case, 10 different cavities in a total of 40 features in my block. And here is my list of pricing. In this case, I don't have all the pricing well, the pricing are coming really in a table in this file. So really here it is just adding some price for aluminum and for steel. But here we can say this is €2, this is €1, and you can create a database of pricing so that at the end you get really a bill of material of your block with maybe 20% multiplier, and then you have the total cost of your block. So this is an example of how flexible can be an Mbxml file in order to retrieve the information that are relevant for a common quotation. And I can do the quotation for all the blocks that I have made. Let's select a different one. Let me take, let me go here in the folder of the webinar. Let me take a non-rectangular block. This block is something that I made during one of the first webinars. In this case, it was a block with cutouts, block with rectangular cutouts and chamfers, and there were no ring in the block. Aluminum, and again, in this case, the cost per cavity is not there because I didn't put all the informations in my spreadsheet. But as you can see, really the process of processing a file is really fast. And in this case, that's another block. That was the design I made for the mating manifolds, done very quickly. In this case, I have some cost per cavity, and I have also the price for the material, and as well for all the other bottom block. And again, we can really produce a lot of quick documentation that can be used down in our office to get a quotation for our block. There is another macro I built, create drill chart, because maybe instead of only having the list of what is there in your block, I want to be able to create on the fly a drill chart without the need to even create a machine drawing. So let me take the same block, the webinar Mbxml. And now in this case, MDTools is just creating my table with all the cavities, all the cavity name, the diameter and depth, the thread and the depth. This is just an exercise where I don't have X and Y position for the face, but it's just a list of everything that is in the block, extracted directly from the Mbxml file. And live, I can do the same for the mating manifold top block. As you can see, we have NG7, we have NG5, M10, some plugs, and all the informations there. So basically, there is a lot of information in the Mbxml file. We have a customer that is trying to build on its own a CAM software to produce the block, taking all the information in the Mbxml file, and it is very flexible. In this case, what I brought is really few macros in Excel that really take the information from the Mbxml file and then store and add to Excel. Of course, it requires a bit of understanding of programming and Visual Basic in Excel, but I think that in any organization there can be people that have some skills for programming, and of course, otherwise we could help with providing some techniques.
One thing that I wanted to ask you to share with the group here is you talked about the Mbxml in multiple aspects. Would you recommend that MDTools customers regularly save an Mbxml structure in addition to the saving it in the native format? Is there an advantage over doing that, as you talked about the portability between version levels and platforms?
I think that if you don't do anything else than just the design, this is not really needed. But when it is up to sharing your design with a customer, And if you are interested in Manifold Edge, then really sharing the Mbxml is a good, very, very important. But just an example, yesterday I was supporting a customer here in Italy, and he was he had asked me some custom utilities to develop in his inventor, and then I showed him, hey, look at what I can do from an Mbxml file. And when I showed him this quotation, he said, wow, this is exactly what we do. This is exactly the same process we do, and this is what I do manually. And if really I can automate this process in few steps, and what I need to do is just press a button in the block and generate an Mbxml file, then why should I spend the time in filling manually a list of cavities? Really, the advantage here is that the information is of easy reach from any other application, because it's a structured file that is easy really to be manipulated and read. Of course, there are some limitations, because if you do very strange shaped blocks, then it is not possible to really have all those strange geometries in the Mbxml file. Although, let me check if online I have that non-rectangular block. Yes, it is here. This is the block that we have. I have designed during my my webinar. So this is technically doable, but there can be other shapes where really you are not able to view the entire geometry in the Mbxml file. So still, the native file is better. But I recommend to store the Mbxml file for really anything additional that you want to do with taking information from the block, because it's very difficult to read the information inside a SolidWorks file or an inventor file, and unless you really run all the commands. But in this case, technically, we could even just make the 3D model and extract the Mbxml file, and then do whatever we want with the information in that file, without really wasting time for a machine drawing. And maybe for a quotation, a rapid quotation to the customer, we don't waste time in preparing a 3D drawing for our shop floor and manufacturer, and that must spend time in analyzing. Giving a quick drill chart will probably be enough to get adequate quotation.